Everyone, welcome back to our part 20 of our RAG powered AI application. In today's video, we are going to understand a line by line code how we can integrate a RESTful API endpoint. In our last video, I explained what kind of intelligence we will get when we integrate a RESTful API as an additional data source to build our context for our query. In today's video, I'm just gonna each and every line of code how we can do that, right? So as always, we are going to define a very high level logic flow, how the code will work or what would be the logical flow of our code. So the very first thing which we have to do is to make a GET request to the API server, right? And we know that what we are using an open trivia database, and just to configure our API endpoint, what we need to make a changes to our config.py. But before that, since we are going to make a request with the request library, so what we need this library, this dependency install, which you can do by just running a pip install request, right? Once we have that, then what we need once we just make a GET request, then we get a response and we have to pass that to just extract the data. Since we are using an open TDB data, TDB RESTful app server, which we know that it provides us questions and answers, right? Then what, it's the same flow which we have been doing for other data source. Like once we have a data, then we have to just create a chunk. Once we have a chunk, because we have a setting through which we control the chunking size. Once we have that chunk, then we just use the embedding model to create an embedding. And once embedding is done, then we load the data to the vector database. In our case, we are using Pinecone. And the rest of the flow is straightforward. Whenever user is going to raise a question, through vector similarity, we will get the more number of documents. We set up that for 10. Then, whatever the 10 records we get, we just feed into the re-rank model, which, converts those 10 documents in the most accurate 3 documents, which actually gets aligned with our query to just make a prompt with the proper context, and then request is just raised to the Gemini model, which is a large language model, and we get the response, right? So we have install the dependency. The next thing which we have to do, we have to just make the changes in config.py. So this is the configuration changes which we have to make. I just open a config.py. Let me just explain what all fields I have added. This is just a web API URL. This API this is opentdb.com API.php. You can open that and you can search for that. And then what we are saying, the default value is 20. We are giving our user a flexibility through the front end where it can be changed. The API default category ID, we are just initializing as known, and the difficult level is also known. We can add that, but that is not something which we will be needing for now. The most important part is the URL. Because rest of the URL, rest of the parameter which we will be accepting through the UI, and we are going to include that in the base URL that you're gonna see in a minute, right? The next thing, we have to build a base, the backend. For the backend, it means we have to just create an ingestion, and for that we always do the same thing. API ingestion Python file, and I have already written a code for that. So I'm just going to copy paste, and then I'll explain each and every line of the. Okay. Again, the code is pretty much same. The only difference is how we are making a request, right? So we have just imported request library and the HTML library because we have to decode some HTML content. It we just get as a response, right? So this is a function which is ingest API data to Pinecone. So just see what all parameter we are accepting, because based on this, we have to define our UI part. So we need number of questions, which is being defaulted with the API default number question, which we have defined in a config, as I mentioned, that we will be driving through the UI. Similarly, with the category ID, again, this is another which we have just initialized as none, right? But here we are saying, okay, whatever value we have in our config.py, it is being defaulted with that. So it means that we have to just get this through the UI. Same with the batch size. Batch size is just to ensure that if the response is very huge, then we can just create a proper batch, right? Here we are just checking, the required, field which we getting from the UI. We are just, we are just casting with the integer so that we are safe. So this is not something which we should be worried about. This part, until this part, this is just a validation which we are doing, right? This is where we are actually trying to build our URL. So this is a parameters section where we are saying amount and type. If you just follow along, here we have this is how, the URL, how we can create a URL. So let me just quickly show you that how the URL looks like so that you will understand, how to make it by yourself. Okay. So come here, you can just paste in here, opentdb.com. You can just go to the API and you can say 10 numbers, any category, you can just select something like computer. Just keep everything as is. You can just make it 20. If you just get a API URL, then you will require, until this point, this we have in our config, then we need these two parameters, amount and category. So this is what actually we are doing in our code, right? So we are just building a parameter based on amount and type, right? So type is again, here we can see multiple choice or whatever type we want, right? Multiple choice and true and false, right? Similarly, category ID, we should not be worried about that for now. If this category ID is being is coming from the UI, then it's just checking whether it's none or not. If it is none, if it is not none, then it is just adding this new tag to the parameters, amount, type, and a category. So basically, at this point in time, we will be having 3 tags in our PALMs JSON, right? And then we are just creating, when we are using this base URL along with the parameters, so that on the fly request, module is going to generate this URL through which it is going to make a request to the server, right? Once that happens, we are just extracting the response, okay, in a data, and then we are just checking whether the data is not equal to 0. And if it is not equal to 0, it means that there is some problem, and then we are just checking what kind of problem it is having, right? So no need to worry about this piece, this code. And then what we are doing, we are just trying to get the API result. So what we are saying, if there is a result tag, then just give me a result tag. And we know that what happens when we hit this, right? So let me just quickly show you so that you can understand. Okay, so if I just copy this and run this, let's see what kind of response we get. We just get a response code as 0, and then we get a result. And that is what we are doing here in our code. So we are actually just getting the result tag value, right? And then we are checking if it is blank, then it is saying there is no result being written. So we are just handling that. And then we are initializing the embedding. This rest of the part is going to pretty much same what we have been doing for the other data sources, right? So we are getting a text splitter. When we are just using a text splitter, then we know what exactly we meant. We meant is we are using this class recursive character text splitter, which takes a chunk size and a chunk overlap, and through which we are just making a chunk, right? So this is what we are doing. The HTML library is being used here to unescape, the question. So this is just to clean up, whatever we are getting as a result. Right? So correct answer. So we are just doing a correct answer. So this is not something which we should be worried about. It's just a simple parsing logic, which we always have. How we can just get all these category and difficulty and those kind of stuff. You can just see here how the data looks like. We have some, HTML code, and that's the reason we are using this HTML unescape, just to clean up the data. Right? So once we have this questions, extracted correctly and answer correctly, then we can just create the content the way we are doing. So what we are doing, we are just creating again a string question. We have a questions and then new line, and then we have an answer with the correct answer, right? And then we are just creating a metadata as we have been doing for the other category. And once we have this content and metadata, we are just calling this document class of a line chain, feeding the content and the metadata, and then we are just creating this docs to process our list where we will be just putting all the documents, right? Once this happens, then this is a very simple logic which we are just checking whether our batch size is equal to the batch chunk or not. This is just to ensure that if we have a more number of records, then we will not get into the resource exhaustion, because in Pinecone DB we have a limit to just load the data. So this is just a batching, which is a very standard way of doing a batching for the large database, right? Once that is done, what we are doing here is we are just creating a summary, and we are just requesting to suggest a batch question here. It's a very simple thing. What we are doing, we are just feeding in all the docs for the summary here. So this is a very straightforward thing. If we have something to be summarized, then only we are just calling this. And then we are, if you just see this function generate document summary, generate suggested question, actually we are just making a request to the LLM, right? So this is our generate document summary function, and this is our generate suggested question list. The only difference here is we have this prompt where we are asking to summarize the entire content, and then this is the summary chain. So it's very straightforward, and it's the same logic what we have been following along in this tutorial series. And once we have this summary created and the best 5 question generated, then we are returning code 3 parameters. Right? So this is just an error handling, so we should not be worried about it. Once we have this is done, then we have to just build our front end, right? So we need the new function to be included here. So what we can say ingestion dot API. Okay, and then what we are going to do, we are going to just call this function ingest API data to bind. And then I have already written this code is also pretty much same like for the other data sources. The only difference you will find here is the number of fields which we want, right? So as this function accepts 3 fields, like the number of questions we want, category ID, and the batch size. So that's the reason we have 3 different fields. Everything is same, and these are the 3 output fields. The only difference here is you have to just call the function which we have written in our API injection. So that's it. This is a pretty standard. The only difference is how we are just extracting data. That part is completely different based on what kind of data source we have. So if I haven't made any mistake, then it should work without an issue. So let's quickly run it and see if everything is working fine. So I'm just going to run by the main app. You can use the Gradio as well. Okay, so it's going to take some time. Okay, let's click on this. So now we have API ingestion tab. Okay, now we can see 3 fields. Number of question we need 20. Category ID, for category ID, I showed you in a previous video. What we need is you have to just look at this where I have extracted this, which number belongs to which category. So the first one is 9, which is general knowledge, music, film, blah, blah, blah. Then what we can do, we can say, okay, 19, which is related to the science and mathematics, right? So let's use 19. Batch sizes, right? So once we click, so let's go back to our server side and see what's going on. Successfully fetched 20 records. Looks good. Clear the namespace on a vector DB. Awesome. So now we can see 20 records indexed 20 chunks. So we should come back here. Okay. Successfully ingested. So it is just creating a summary. Okay. So now we can see 20 records, which means that we have requested for the 20 questions. So this looks good. This document is a collection of question and answer covering a variety of topics in mathematics and related fields. This looks good. And these are the 5 questions which we are getting. So what we can see, we can just pick this first one and we can ask this question, which, let's quickly do that. Which famous mathematician mentioned in the document died in a duel at the young age? Okay, let's go back to the server. Okay, so it seems like it just first extracted the 10 documents based on the vector similarity, then 3 documents, generated the answer, come back here. So these are the 3 things. Which of the following famous mathematician died in a duel at the age of 20? Can use. What is the plain curve? Okay, so these are the things which we are getting as a context, and this is the answer, which is the correct one. So now you can play with this. You can just go to this website and you can see what kind of category we have. Since it's a free, you can just also use, and you can just play around your application. You can just use a different category, different numbers. You can include the batch size and the number of questions, and you can just verify the intelligence of this application. So that's it from my side for this video. If you have any feedback or suggestion, please feel free to put that in the comment section, and I would love to incorporate that in my future video. If you really like this video, give a thumbs up, and if you feel this video can help your friends, colleagues, and guru, please feel free to share with them. And if you haven't subscribed for my channel, please subscribe for my channel as well. So as always, thanks for watching this, and stay healthy and keep learning a new thing, and we will meet in a next video. Probably I will be using another data source, which is a time series database, and I didn't decide, which one I'm going to use, probably InfluxDB, but that is something which I will decide and let you know in a next video. So stay tuned for my next video. Thank you.